Okay, so it's me again. So I will try to be quick. So I want to present a small tool called R2M2, and the goal is to bring world peace by making it possible to use radar with miasm. So you know me, so I will skip that. So why did I did this miasm and radar 2 sync? I needed to implement a really weird and exotic CPU architecture really easily. And 1 year ago, the only OpsJump was able to do some stuff with this architecture, which was a bit not that useful. So I decided to build R2M2, and that's just a radar plugin that aims to use radar 2 functionality in order to give a GUI to miasm and use miasm, let's say assembly, the assembly engine, and symbolic execution engine to radar. And I want to be architecture independent, and I want to be really lazy. So adding a new architecture to miasm, and why I choose to do that with miasm, that's really easy. You need to put your register into the rex.py file. You need to define your architecture in arch.py in your instruction. So here I'm adding a really simple instruction with a mips add. So what I do, so you read the documentation, you define the new instruction in miasm, you give it a bit string, so you copy paste the documentation, you give a source register, target register, an immediate, and that's it. You have your instruction definition in miasm. So it's really powerful. For me, it's like SKP for assembly and disassembly. That's really, really cool. And then you need to define arguments, your registers, your immediates, and that's pretty much it. So for someone lazy like me, that's perfect. If you want to tell miasm how to, let's say, execute and give the semantic to of the instruction, you have two choices. Do it the hardcore way, so it's like writing miasm expression, and you don't want to do that. Or you can use this wonderful feature, which is called SemBuilder, so you can just define your Python function, that's your add instruction, and say, okay, add that just adding a source register to an immediate, and put that back into the destination. And if you execute it with miasm, you have your miasm expression. So that's really powerful, and that's not much to do on my side. So R2M2, the goal is to keep the smart logic into miasm and provide radar 2 plugins. So two plugins are provided by R2M2. One is called assembly disassembly. That's the easy one. You can see it here in this output. And the other one is analysis and ASIL, which is something that Julian presented before. That's for emulation. So the easy one, that's just a wrapper using CFFI. So I'm calling Python from C. That's a bit ugly, but it works. It takes a lot of memory, but it's kind of okay. And here I'm using the R2M2 architecture in order to assemble, then I guess disassemble and assemble. So the instruction. So it works. That's a silly example. So I'm using the MSP implementation in miasm on random instruction, so I'm disassembling 5 instructions here. A bit more complicated, binls, x86. That's nice, but here we have jumps. And so far we are only doing assembly and disassembly, which is as useless as OpsJump. So what can we do next is build analysis and ASIL plugin. So that's the challenging one. So I want to use miasm to automatically find branches, function calls, split blocks, emulate instructions. So how I'm doing that, I'm using miasm internal methods. So this one is subcall. So if the instruction is a subcall, then I will fill a specific radar 2 C structure. So it works fine. So again, simple output. So I'm building with miasm and radar a binary with a jump and a nop. And here we can see that radar is able to detect the jump to the next instruction. So it's a bit, again, silly example, but I got like a block splitting for free. Here on top, that's radar 2 with binls by default. And on the bottom, that's radar 2 with miasm backends with this really simple trick. But again, that's kind of useful. Step 2, more complicated, is to take miasm internal expression to ASIL. Again, that's the stuff Julian presented this morning. So miasm expression is something like that. That's kind of big. You have an affectation of an int value. That's my birthday, by the way, into a register. And ASIL, that's like RPN stuff. Like you don't want to mess with that. It's too complicated. And the idea is to convert from miasm to radar on fly. So here I can get also that for free. So I need to expand that. So that's the same example, but I gave radar this ASM.mu stuff. And here he set the PC register to 4. So that's from MIASM semantic to radar really easily. More complex outputs, same stuff with binLS. Again, we need to check that. So he managed to set the 0 flag, the value for EAX, and so on. So now I have my exotic architecture in MIASM. I can use it in radar, and I can also emulate directly in radar. So I can do the stuff that Julien presented this morning, doing, for example, step-by-step or full emulation in radar. Concluding remarks, thank you for MIASM and radar. I think Fabrice told me he will kiss Julien or something like that. So maybe we'll do that. So they are really powerful tools, and indeed combining them will turn out to be really efficient. So R2M2 is not only a POC that only works on my laptop. You can get it on GitHub, and also there is Docker, which is really secure, really nice. So is it too good to be true? Maybe, again, I'm not a reverser, I'm doing network security, that's my job. But that's maybe too good to be true, but at least I'm able to do that. So 1 year ago, I only obj dump, and today I have these basic blocks. I will try to zoom. That's the same stuff as before. So I can't zoom. Sorry, you have to trust me. That's same instructions, but this time I was able to find out blocks and display them, and actually starting to reverse with radar. So again, thank you guys for MIASM and radar. So if you have question, comments, issue, and beers, I'm still there. Thank you.